here to share our knowledge. So since Friday last week, we started this particular session on data structures and algorithm. And I believe it has been productive because some persons have given me feedback that they've learned some things from the whole thing. And it was supposed to run from Friday, Monday through Friday, that's tomorrow. But unfortunately, some of the resource persons were not able to make it. And because of that, we had to cancel, I think, on Wednesday and Tuesday and Wednesday also, or just yesterday. So today we'll be having Mr. Elisha Benjamin. I believe some of us, we've met him before. He was here during our Print F, was the one who took us on Print F, and we saw how productive it was because after his session, I think it took us twice or 3 times, we were able to solve some of the things. So we'll be here with us today to take the concept of arrays and linked lists, which we were supposed to do on Monday, but unfortunately, he was not here with us. So today we'll be tackling arrays and linked lists. And then by tomorrow, we'll be concluding on the whole thing, hopefully, that the person we're expecting will be able to make it. If he does, he's going to conclude on the whole meet and give us practical examples of how the whole data structures and algorithms are applied in a real-life situation. And then he will show us some codes on how to implement them. So we look forward to having him tomorrow if he will be chanced. So I would just want to run a check for some of us that were here on Friday and Monday previously. I would love to know what we learned from the session. So if you were here on Friday and Monday, I think on Tuesday, I don't know if we had something on Tuesday, but if you were here in the previous sessions on data structures and algorithms, I would love you to share with us what you learned in case some of us were not here, so we could also learn from you. So if you want to speak, you can raise your hand up and I will give you the chance to speak. So now is the time. So now, while I'm waiting for us to raise our hands up so we could speak, I want to encourage us to open our mind to learn today too, because the person coming is someone that is very productive, as I always say, he has it in him. So when you feel you don't understand anything, or always ask him and don't interrupt him. The way you could ask is to raise up your hand, and mostly he is not always on the screen. Yes, so I will definitely alert him that someone is raising up their hands, and then he will give you the chance to speak. But don't interrupt him because he might be saying something important and you end up interrupting him, and others may lose concentration on that. So anybody, I asked for those that were here on the previous sessions on data structures and algorithms, what did you learn from the session? So while we are waiting for our resource person to come, I would love us to share our knowledge in case some of us were not here. Anybody? Okay, Akpan Joseph, okay, I will hear from you.
Okay, good evening, everyone.
Yeah, good evening.
Please, the last class was on, he was showing us a diagram of a tree diagram. How they connect with each other. But we couldn't hold the class very well because of network. So he said he's going to drop a video with you. I don't know, maybe we drop it. And I said when he comes next, he will now explain more better. I think UM too was here. UM was one that coordinated the class then. So he was only talking about the tree diagram and how they connect with each other. So that was when the network started.
Okay, great. Okay, I was not available that particular day because my network was really bad, and then my laptop, I couldn't use my laptop then, and I was trying to join with my phone. My network was really bad, so I was not available that day. But I heard the report that network was bad and he was unable to really host the class. So I spoke with him. He said he was going to drop the resources, so he has not dropped it yet, but after this session now I'll go back and remind him so he could either give me or do a video as promised so I could share it with us. Definitely he will. So if possible, I will have him again and we'll see how he could break down those things, because he came prepared though, but as network will do his things. So please, apologies for that. I'll remind him after now. Okay,
Okay,
Afan.
sir. Yes, sir. Thank you. Yes.
Okay, thank you. Okay, so is there any other person who wants to share what he or she learned from the previous sessions on data structures and algorithms? Any other person from, it does not have to be on Monday alone, like we started on Friday. So whatever you must have learned during the previous sessions on data structures and algorithms, please share with us, so that for those of us that were not around, we could also learn from you. Anybody willing to share? You don't have to share the whole thing. You could just tell us one point you picked, and that would be okay, and that might be what someone really, really needs. Anybody, or I will call somebody, because I recognize some of us were here. Anybody? Okay, so nobody's willing to speak, but I believe we all learn a few things from the session. So I will just call a random name here, and you just tell us what you learned from the previous session, because definitely you must have picked something. So the first name I'm seeing on the screen here is Pascal. Pascal, please share with us, what did you learn from our previous session on data structures and algorithms?
Mr. David, good evening.
Okay, good evening, sir.
Good evening, everybody in the house. First of all, I wasn't even in the class for that day. I was trying to come in and nobody gave me access. I was at the door for almost 30 minutes. Nothing. I was posting in the group, but no response was coming from me. It was at the end of the class that I was told that you were not even in the class yourself, that your network was bad. And we were told in the group also that the video of that class will be sent. So many of us were waiting for that response from the man that took us on that very class. So I was not even in that very class that day. So please, if we have a hold of that video, it's going to make sense to us. Thank you.
Oh, okay, no problems on that. And apologies for that. That particular day I was unavailable. And usually I join with my laptop, and then I will turn on the auto admit, so anybody could just join. But that day my laptop was unavailable, so there was nothing. And I was admitting people with my phone, and before I knew it, I think my phone went off that day. Yes, my phone went off, so I was unable to do anything at that point. So apologies for that. So hopefully after now I'll remind him, as I said, and definitely we'll have a video on that. And thank you. So our resource person just reached out to me now. He said he'll be joining us in the next 1 minute. So before you join us, please, is there any other person who wants to share what he or she learned from the last session on, not the last session, on the previous sessions, any session at all on the data structures and algorithms? Because some of us were not here. Like me, I was not here on Monday. So if you share with us now, I may pick a few things, and that may be all I need. Anybody? I might just have to call a name. Mr. Dixon, please tell us something. Is Mr. Dixon there? Okay, he might be unavailable there. Okay, Mr. Owen, please tell us something. You were our moderator on Monday, I believe. So please tell us.
I was just trying to hide behind my computer. Hey, everybody, good evening.
Okay, good evening, sir.
Okay. Thank you very much, sir. Oh, well, I think I'll just make a little reference to the last meet, especially since you were not available on account of your battery running down. Those who were here, I think they'll attest that actually the sound was a little bit of a challenge. Actually, we had to wrap it up before even the actual time, I guess, that the guests would have loved to wrap up because of the challenge. But what I got that day the little I was able to get was that he was talking about something called, I think, from my understanding, was something called trees and graphs. I found it interesting anyway, just that I couldn't get the full grasp on it because of the sound. But he did have somebody using an app to draw diagrams to show us what he was talking about. And he had the person draw like circles. He called them nodes, actually. And then he had like 3 of them in a line, and then he had the person join them with a line, all the circles. And then he said that's how the kind of things I got was that when the lines are in certain direction, then it's like a directional connection. And sometimes when it's just connected without like an arrow pointing in any direction, it is not directional. And he told us about like how when one of the nodes is cut off from the connection, it becomes a breach. Then he tried to explain that those nodes could be used like social media networks where they'll all contain information about users, like their real names, their usernames, date of birth, sex, and stuff like that, and how those kind of things can be adapted in social media use. Those are the kind of things I got from that day. That's in brief. Thank you. Don't tell me everybody got stunned into silence. Earth to moon, anybody there?
I can hear you, Mr. Wem. You've summarized
everything. I was
everything.
talking to myself.
Okay.
That work on Bobadi.
You're okay.
All right. Thank you, guys.
I think Mr. Wem, you should coordinate.
If Mr. Davis, sorry?
You see, we should coordinate. You see, Mr. Davis not.
Yeah, I think he may have dropped out. I don't know. Sorry, Mr. Elijah. Oh, Elisha, sorry. I'm sorry, sir. Mr. Elisha, please.
Yeah, good evening. Good evening, everyone.
Hey, good evening, sir.
Good evening, sir.
Nice to see you again.
Nice to be here with you guys. Always fun.
Thank you so much, Kobe. Thank you for always helping out.
Yeah.
So you're welcome, sir.
All right, thank you.
Okay, I think David is back. Maybe he may want to continue. Mr. David. Hello, David.
Okay. Yes, I'm here now. I'm sorry, I lost out there for a minute. Okay, thank you very much. I got a few things from what you said. Okay, so I wouldn't waste our time because our resource person is here. And I'm sure we've met him, but for those of us who haven't met him, this is Mr. Elisha Benjamin from Cohort 8. So he has been with us for a while. He took us on printf, on Simple Shell and all other concepts in our program. And we've seen how he's able to break down concepts to little pieces so we could really understand it. So from time to time, I tend to reach out to him for him to help me out on some things, and he always answer me. So today he's with us today to take us on the concept of arrays and linked lists. So please, with your clapping emojis, help me welcome Mr. Elisha. I hand over the mic to you, sir. Thank you.
David. Thank you for that introduction. Thank you, everyone. Thank you for the clapping. It's always wonderful being with you guys here to share knowledge, and also whenever I'm with you guys like this, I always go back more better and I learn one or two from you. So today we'll be looking at array, then we'll look at linked list. So, and I think most of the times those concepts, we understand the concept, but when it comes to applied with programs, in a particular program, then we have some challenges because the program that we are using to implement those concepts sometimes, I guess everyone can hear me.
I can hear you, sir.
Yes, I can hear you.
I can hear you, Mr.
Right. So I guess that particular language that we're using to implement that concept, we may not understand that language in depth, or there are some things that are happening that particular language, the way it handles some things, we didn't actually get what's happening. So if you don't have that picture also, you are trying to implement the concept which you know, you find it difficult because the language that you are using, you don't have full understanding of it, or the concept itself, you don't understand the concept. So today I would like to, there are some things that I find it difficult. Then when I was being introduced to it first time, so those things I have to go back and learn. When I understand those things, it becomes so clear and I understand it even more in depth. So I would like to share those things with you so that you understand those things. Then once we try to implement it, you'll see how easy it's going to be. So, and today I guess we're using C to do that, right? Hello?
Okay, sure, sir.
Yes, so if we're
Yes,
using
sir,
C, okay, if we're using C, so there's few things that we need to look at. So I'll be sharing my screen now. We'll just look at one or two. Today I will try as much to make the class brief. So let me share my entire screen. If you can see my screen, just indicate, please.
of course.
All right. So this is what I just want us to review. I want us to review memory in C, memory allocation, pass by value, pass by reference, and type def, struct, and linked list itself. So we'll just go through them and we'll just do the explanation here on the dashboard. So I'm using Figma 2 here for the demonstration. So first of all, we'll look at what memory, I guess. Let me not just assume that everybody understands it, but we'll just quickly rush through it. So we know that array, they are basically consecutive memory block. That's memories block in C language. That means what literally means is the memory are allocated, they follow each other. There is no space between them. So if the memory starts from address 100, the next one would be 1001, 1002, 1003, and so forth. So that's how the memory follow each other. So there is no break, like you find one at 1009, the other one 1006 or 10010. So they are not scattered, they are together, they follow each other. So what I'm basically saying is, let's assume this a memory. So let me make a duplicate of this. So let's say this another memory. So this another one. Let's say this another memory block. So each of these, they have their addresses. So let's assume that this is 101. This one should be 102. This should be 103, and as you may guess, this should be 104, and you're right. So this is how array is being arranged. Array, you will never find an array that the next block that it saves its value here will be somewhat disjointed. Let me see, you have 301 address here, then you still have 103, and you'll never find such like this. So what C normally does is it makes sure that it has that enough memory space that they follow each other to allocate for that particular array. So once you are accessing the array, once you know the first address, the address of the first memory block, you'll be able to find the second one, the third one, and the fourth one using your indexes. So, and our index starts from 0, 1, 2, 3, so and so forth. So if he's returning this memory 101, if you try to access the array at index 0, so what basically that one means is you are accessing 101 plus 0 is still 1010, right? Then if you add 1 to it, you have something like okay, let me correct this. It should be 1. So from here, if you add, let's see, here is, let me use text. Let's see, we have text here. We have here is 0. So we have 1 as the index. We have 2 as index. Here, let me see, this is 2, then we have so we have 3 here. So this basically what I'm talking about is just indexing. So if you add, it will return the address to you. So but the address, once you add 0 to it, it gives you still the same thing. You still arrive at 101 address. So it's still that address you get. So but if you add 1 to this address, you get what? 102. You add 2 to this same address, you get 103. You add 3 to this address, you get 104. So just know that even that indexing, that's what happened behind the scene. So it's just adding these values to that first address to get the next address. So if you want that's why you see that the first one is always starting at index 0, because he wants to add 0 to the first one. So that's how the memory allocation is. So, and we know that like characters, they have number of memory block that is being allocated to them to save one particular character in C. Hello, are you guys still with me?
I'm with you, sir.
All right.
Yes, sir, we are with you. Design.
All right. So that's it for now. Just, I know you know these things already. You must have read about it severally. You've gone through it. So I think I'm not saying something strange here. I'm just trying to draw our attention to it. Just know that, okay, we need to put it at the back of our mind going forward, that this is what is happening behind the scene. So just like if a single character is being saved, is used 8 bytes, right? Hello?
Yes, sir, we're here.
Yes, we are with you, sir.
All right. If you are saving single character in C, how many bytes do you need? Anyone can answer it. Just I want today to be interactive. Let me not be talking a lot.
That should be 4.
Okay, you're right. It's 4. So let's assume we just want to save one character. So he's going to allocate these particular 4 memory blocks to us to save only one character. So, but mind you, when he's returning it for that particular character, after saving it, the memory address is returning this first one. So it's not going to return this one. So it will return this one. So, but once you try to display the character, it's actually this particular one that you use. Then it will go ahead to read the entire address, because there is always a null extra memory block that it will keep at the end for you to mark the end of a string, if it is a string. So let's say if we are saving 2 characters as a string, we will need 8. So that means we have to double these 2. Let me see. Sorry. Control G. Let me group it. Control G. So let's see. So this first 4 will be Brad. So this will start with 0, 1, 2, 3, 4. Then here will be our tell us date. So just see exactly what's happening. To 1, 2, 3, 4. So, but it's not the entire memory block that is returning for you as an address. He will always return the first memory block to you as an address of that particular character, but he's actually using 4 memory block to save that single character. So he will return this one. So, but your index now will be this first one. This is your index. So, but he knows that it's 4 that he's going to need for that particular single character. So the same thing with this one. So the next index now will start here. So that's in the case that we are using what? 4 memory block to save one single character. So that's how the index goes. You can see how it goes. So if he already knows, when you are doing the memory allocation, you already define that, okay, these are the number of memory block you need, and you already say that it's character that you want to save inside. So the C program language already knows that, okay, I'm going to save the first 4 for the first character, second 4 for the second character. So this array way of doing it, this is how array save is. His values, they are always arranged together. So the shortcomings of this is that sometimes you may use up your memory and there is no enough. You need 8 memory space, and imagine that there is no up to that 8 consecutive memory space. In some places there is already value saved here, like let's say they have already used this, he used this memory for something else, and he used this for something else, and you need 4. So array cannot help you out. So he will return error. That means the memory allocation failed. So that's where linked list comes into play. It helps you to mitigate that. So with that said, enough with the memory. Let's look at memory allocation. So I have talked about it also just a little now. So, but what I want to talk about is the dynamic memory allocation. So that means you are in charge of it now. The system is not the one doing the allocation. You are determining, you are asking for a specific memory that, okay, I want this certain amount of memory to save something. So you are doing it, you are allocating the memory yourself, not automatically. The program is not the one handling the memory allocation. You are using sort of functions to tell the language to, okay, I need this particular so memory space on the system to store. So that's where memory allocation comes in. And we have malloc, which is the most popular one. We have uh,
can recover this stuff.
Let's say this one is 0.2. And this 1.03. Okay. Then this one 1.04. See, these are addresses. Then on this particular one, we save the 3 using what? 3 is saved here in this particular address. As on this 0. This 0. Can you guys even see it? Sorry.
I can see it.
Yeah, all right. So, now, this particular statement that we just written now, we're just saying that, okay, we've already told C program that, okay, we need a memory that we want to save an integer. Then immediately we pass 3 to it to help us save in that particular memory. And he went ahead to do that. So this is what he went ahead and do behind the scene. He find a memory with address 01 and he save it here. Then this n that he returned now is this address that he returned that n is holding. So whenever you call n, it's the same thing as saying you are calling memory 101. So once you have this memory at hand, you can get this value 3. So that's the same thing with this n. So when they say pass by value, what they mean is you are not just passing the address into this function, because this function is expecting an integer, right? So if we come down here to call this function down here somewhere here to execute it, we say num open bracket and pass 90, right? So, let me do it properly. Let's say int result equals to num open bracket. I say it. Let me say 10. What I basically do here, I pass value to this guy, to this function here. So he will go ahead and do the multiplication. This is value that I actually passed. I actually passed the value. I'm not passing reference address to this particular function. So I'm passing the value. So the same thing, if I try to pass in, if I say n here, we already have n here. It's not going to pass in this address to this guy. This n is going to evaluate to 3 in the memory space and pass in 3 to this function, and this function will go ahead and do the multiplication, then return the result and the value. Once it returns it, we're going to save it here in our result, and we have that in our result. So that's what's happening. So, but there is what we call pass by reference. So doing this, you are just passing it by value. So it's going to resolve this thing to 3. This particular n variable is going to resolve it to 3 if you call it this way. So in the function, what you are going to be receiving as x is 3. Actually, you'll be receiving, not n, not the address, this 101. So, but by reference, if I do something like this, now what I'm doing now, I'm passing it by what? By reference. So, and there is something that will happen here. If I try to say, okay, I want to change x, I say now, I come back here and I say inside my function, inside my function before returning this guy. Let me see. Okay. Let me elaborate it. See. So before returning this guy, if I try to do x is equals to, let me say, 5 here, what will happen is this x that you're saying as a variable is holding 3. So basically, I'm going to change what this variable is defined within this function. So it's a whole new variable that has what 5. It's basically happening. What is happening is just saying that x is equals to 3 here. So it's the same thing like this, saying this with just passing this n like this. So this is what he's saying, that okay, this is the value of x. I'm passing x to you is 3. So once you are using it, if you say x is equals to 5, it's not going to change this n that is outside here. No. Well, let me even make it so that you see what I'm saying. So I use the x so that I will differentiate this. But if I do n here, so you know that this n that is here is different from this n that is outside here. This n now is defined within this block of code. So these two n, they are two different n. So this n now, this is basically what I'm saying. If I do this, so is this n I'm trying to pass the value. So I'm passing it by value. So it comes in here. And this just the simple definition of what is happening in between this line. So it's just saying that okay, it's a new variable. It's a local variable called n that has a value 3. So this is what it's just saying, that okay, this value is defined within this block. So anything outside here, this n doesn't have anything to do with this outside here. So if so if I call this n now, it's different from this, right? So let me return this back to x. That's what I just want you. So it's a good practice to keep your definition distinct. So you know that okay, this value passed and we generate a local variable here, and this is what we are using it to and return. But if we go ahead, because this has resolved towards to 3, so that's why we're having this x with 3. So but this is just it. So I just put that equals to tell you that okay, x is actually equals to 3 if we do it like this. So it's passing that 3 to it. But if we put this ampersand sign here, we are passing the address of n to it. So it's actually this memory location that we are passing. So we're saying that okay, here now, x is not actually a number but a pointer. So x now becomes a pointer. So it's actually a pointer that we are passing to this guy. So here now becomes is holding an address of of x. So now if you go ahead to call this x like this and pass in 5, this value outside here, this n that you are seeing, is going to change to 5, because it's this address that you are calling outside here, this particular address, and you are saying that okay, I want to say 5 inside that address, because now you've passed the address to this function. So it will come here and put 5 here by this now. So now this particular that you did here is passing, you're passing by what? By reference. So it's referencing, you're referencing a particular memory. So you're not just passing the value. So I guess this is clear, right? Hello?
Yeah.
Yeah, yeah.
Well, so far so
It's
good.
clear. It's clear, sir.
So, do you enjoy this that I just shared now? Are you okay with it? I guess it clears some things for you.
Yeah. I could do with a little
Okay.
more though.
This
Well,
answer now.
if I may ask,
Yes, please go ahead.
the first variable you actually declared that was equal to 3.
Yes,
Yeah, that's a global variable. Now you now declare another variable x that is equal
yes,
to 5. The
Yeah.
same name, and this one has another precedence. It's now a local variable.
local
I
variable.
think if you are declaring variable like this, I think this newer one will actually replace the first one.
No, because this guy is already hidden by this function. So this
Okay,
function,
okay.
yes, is hidden by this function. What it will do is that he will know that okay, n is coming from what? From the parameter here. So he knows that okay, this n is different from this n.
Okay.
You understand? So even though if I put n here, it will still work, but there are two different n. This n is different from this. So you as a person, you are seeing n and n, they are the same, right?
Yes.
But in the real sense, there are two different memory space. But it's just that he's using n and n to represent it. You are naming it n here as a local variable, and you have n there as a global variable. So, but him behind, he already knows that okay, this n there, his address is different from this address here. So if I do another n here as a local variable, he may come and save that particular other n here, somewhere here, the value. Let me see, if I say 3 here, we do it that way. Maybe he will come and even save it here. So you can see this address and this address are not the same. Because here we declare this and we pass. Let me see. If I do it this way, let me explain this. You say this n equals to 5, and let's see, n equals to this times this. So what is happening here is you're already declaring that okay, I'm going to receive n. So what C would do, will still go and create another memory space. You are telling me that okay, I need a memory space, I'm going to save an integer, but you've not passed the integer to it yet. So you are telling him to expect an integer. So what he will do is just to go and reserve a memory space for you somewhere that is free. He will still go and reserve a space, but this time around he may make it 0. But let's say that okay, this is it. But this variable now is just a name. This n is just a name. But him, you already know that this local one is different from this one. Understood?
Understood.
Yes. So is the address that is the main thing that the C is looking at. So is the addressing that I'm trying to point out to you, that sometimes you will see that they've done those linked lists, they've created a linked list. So instead of passing the address of the first node of the linked list, they will go and pass the address of the header of that linked list, not actually the value that of the first node of the linked list. So they are passing the address of the header itself. So now you have to what? First of all, get the value of what the first node through the header address that they give you. So you will see it once we get to the linked list. So the next thing is type definition. So it's also a way of defining your own custom data type. So we have we have int, we have string, and what again?
Bool.
We have boolean, right?
Yes.
Car.
Yeah, we have character.
Character.
Yes. So those ones are primitive data types. So those ones are data that are already defined within the C language. So but you can also construct your own data type by yourself. So you use struct and type def. So I always like using this type def. So let me show you something here that they are doing on this here. Where's the material? So here you can see like this particular tags that they give you. You can still see my screen, right?
Yes.
Yes.
Yeah. Yes.
All right. So struct, you are trying to say you are defining a new structure. You understand? So type def is just you are naming it. You are going to give it a name. So we can rename. We can create a variable of type int, but we'll name it another type. Something you can do something like this and say. Let me just delete this. Delete this one. So we can actually do something like type define. We'll say int. Then we'll say. Sorry, David, I'm using your name. In David, the okay, yes. So if I do something like this, what this basically means is I'm defining a new variable. But this variable, this is the name that I'm going to call this variable, David. But his type is actually int. So I'm using primitive data type to define another name. So you know when we are declaring our variables, we can do something like int and say num and have something like car and say C. We can call it C. You understand? So here now, I can come and do, by virtue of this that I just did here, I can come and do something like this. David here and do something like B, which is, and say B is equals to 4. So this will still stand now. I have defined a new data type of my own. So I'll define a new one, naming it what? David. So, but this one, I take advantage of what? The primitive data type to do this. You understand? So this still David is still an kind of an integer. So I build it from a primitive data type. So I can go ahead and start using it. So whenever I do this, he will still do the same allocation that he will do for an integer, this num, and the C program will still go ahead and do the data allocation, the memory allocation for me, and save it and put 4 in that memory space. So then struct, in the other hand, is kind of defining a whole new structure. So if I do something like struct, then I say, let me call it node, since we are working with nodes. If I say node, then I do something like this. So I say something like int n, and I do another one. I say car. And this is for string, right? I just do something like this. So by virtue of this, I just define a new kind of data it defined another data. But now I'm not just using that type definition that I use, that type diff that I'm using. Because what type diff does is it allows me to what? Manipulate just one particular uh to combine just one value and change it, give it another name, then continue using that particular name. But in this case, you can see I'm creating a kind of dynamic kind of data structure. So this this structure stands for a structure. Just know that. So you are defining a new structure. So the first value inside that structure is an integer. The second one is a string. So whenever you want to create something from this, you can declare it like this and say struct node. You can say node 1. Say node 1 is equals to, I can do something like this. And I would say first one is integer, so I can say something like 5 comma is string, and do something like this. And I will say so if I do this now, this is a structure. I just define and I instantiate that particular word structure, and I define, see the definition here. This is what I did, and you can see this is a kind of a data type that we just defined, because this is data type here, and this is where I defined it. You can see it here. This is where I define it, and so that's why I'm using this, still using this struct node, saying that okay, it's a node that I'm defining, and this node, this is the name of the node. Going further from here, I'll be referencing it. So the address after creating this, the first address that is going to return, is going to assign a space that we can keep an integer and also a string here. So you keep that particular memory space for me. The C, we're going to arrange that. So if you have this now, I can go ahead and access this first value by just calling, access it by saying, okay, node 1, this. I can use dot actually. I can use dot and say n, because here inside the class, the variable name is n, so I can do n. And this is going to what? Resolve to this 5 here. So the same thing is going to happen, that if I do if I do dot I do node 1 dot string, so it's still going to return this second one for me. So you can see I've defined a particular word structure using this. But if I don't want to use this node here, this is an entire structure. So this is a kind of what? Data type. From here to here is what? It's a data type. So, and you know, the last time that we did that first one, I did something like type Dave, then I do int, and I say David. I'm not mistaken. So there's something I want to show you here. So this one, you know that it's a data type. So now we've defined our own custom data type, this. So here too, this guy now and this guy, they are almost like, okay, the same now, but the difference now is this one is coming with C, but now we're defining our own ourselves. After defining it, we give it whatever, what the structure that we want to make it inside. Then after having that structure, then follows by what? The name that we're going to be referencing this new structure that we just have. So in this case, you will see them doing, you will see most of the times they will do like this, type B stroke, then outside here, they may give it name, let's say, node underscore, let me say T. You understand? So this is the same thing. He's just doing the same thing here, saying that, okay, this is a data type here, this int n here, this entire thing is a data type. So the same thing here, this is it, this one here, then this is the name that you'll be referencing this. So David here is the name. So it's the same thing like this. So you can see, so if we check here, you can see what they're doing here. They're saying, okay, type dev, then they do the struct. So from here to here is a new structure that we just define, a custom structure. Then here, this is the name that you'll be calling it. If you say list T, so you're just saying that, okay, this particular what structure, that's what you're calling here. So you don't have to go, when you're calling it again, you don't have to be referencing, saying stroke. You can see here when I was creating it, I have to say what? A node, stroke node. So here, if I've done that, I don't need to put this stroke here. If I did something like this, I would just say node underscore T. That's okay. It's already okay because I already after defining it, I changed the name. I say, okay, I just want to be referencing it with node T. So whenever he says node T, he knows that, okay, I've already defined it here, and this is it. So first time that I encountered this, what I just did is just to put this at the back of my mind. Is just like a renaming, function. Hello?
Yeah, I can hear you. Yes, function. Yes.
Okay. So it just helped me to rename primitive or any kind of defined data type. It helps me to rename it. So that's how I look at it. So this a data type that we define and we are renaming it to this. So basically this is what it is, and this is what this particular code is. So, and in this particular section of this project, you can see they say that, okay, use this particular for the entire project. So if you are using this structure now, this is it. So same thing, if you are allocating a memory now, you want to save a, where is it? Okay. So now, where our attention should go is when we are allocating memory to this. We're saying we want to do malloc now. So if we say, we have nodes, so let me say node T now. I'll call it node 1. So I want to allocate memory to this particular word. I want to save one of these node here inside this place. So if I do malloc here, I say size of, that's it, right? So I say node P.
The malloc is double L. It's supposed to be double L.
Okay, thank you. So you have this, then you say size of this, then you say if it's just single one I want to create, I will just leave it like this. Say okay, it's just single one that I want to create, so I leave it like this. So but if I want to create more than one, I can multiply it and say okay, I want to create 3 of it, give me 3 of it. I'll go ahead. So it's going to create a row like 3 of it. It's going to create it for me. So I have the same thing as array. Now I'm creating it like an array now, but I'm assigning the memory block in what consecutive what row. So what malloc will do is it will create them 4 together. So what it does is it will come here and calculate the size of this struct that I just created. So he will do for int. He knows that okay, an integer carries 1 memory block, then this one character carries 4. You combine 1 plus 4, making it 5. So he will add that up, then that will be the size based on my machine that I'm using. So if this is the machine, the memory design is it uses 4 and 1 for integer and 4 for character. So it's going to return 4 for me here. It's going to return 5 for me here. Then if I say multiply by 4, so that means it's going to preserve a space for me to save 4 of these types in that memory block. So that's where you will see them using this to create it. But if I just do only this, so it's just going to create for just one. So I will have that, and you will return it here. The address. So it's going to return the first address of this. So this entire structure that is going to create and allocate the memory space. So it's the first memory space, like I said before, is going to return the first one. So if it returns that first one, so with that first one, I can access the remaining ones, right? I can use index and access the remaining ones. So, what next that I want us to look at? So we did the type of dev and we do the struct. So let's look at linked list itself. So to understand linked list, we have to look at array itself and the linked list. Then we have a clearer view of it. Then we go ahead to do our implementation and try and then look at the algorithm side of it. So the algorithm side of it is just step-by-step process on how to manipulate it, save data in it, make it more efficient, how to retrieve our data, what's the time complexity, what's the space complexity, and we look at some of the advantages and disadvantages also. So I started with array, then I was making reference that array is in consecutive memory block. So but what linked list does is it has one kind of addressing structure. Linked list is that it keeps the address of the next node. The next node doesn't really has to be consecutive like this. They don't have to be together. Like array, the next node in the array, I'm saying array, the next item, let's just call it node. The next node in an array has to be the next address. So they are always like this. Array will always force you that, okay, this is how it's going to be. They are going to be what? Together. Their address are going to start with 0, 1, 1. If you start allocating it from 0, 1, 1, the next one just expect it that it's going to be 1, 0, 2, the next one 1, 0, 3, and so forth. So, but in linked list, what we are doing is that once you create the first one, you have a space that you can keep the address of the next memory block. So the next memory block doesn't have to come from, let me do something. Control G.
I don't understand this thing.
So let me do this. So let's say this is a note. Okay, what I will do, let me just decorate it properly. Let me create another one. Say this. Control V. Let me give this one color green. Let me say so it's a single linked list. Let me say this should carry and this should be the our value. So this one too has an address. Let me say this one would be two. Okay. So this a note. We have a note here. What will be here is it's just going to be a pointer that keeps, and we know what pointer is. Pointer is just a variable that keeps the address of another variable of the same data type. So if we have address like let's say 106 here, and here it just keeps the value for us here. So you have, let's say you have 5 here. This one keeps a normal integer value, while this keeps an address of another memory space. So imagine that, how will I put this? We have address. Okay. This is the address of this particular n, and this is it for this one. So once we do that malloc and we created this value, we created that first node, this is what is going to return. It's going to allocate the memory. It can be longer than this. If this is 4, so that means the first value for this memory block. If this is just an integer, let's say assign this one, then the next one, if it is a character, which is 4, so we're going to have 1 plus 4, which is 5. So, but it's going to start from 1, 2, 2, 1, 0, 5. So that's what is going to happen to this. So this is what this memory, if it is a character that we are saving here, but it's not a character, it's an address of another node that we're going to create. So he's kind of linking the two together. He links one note to another note. So he has a space that he keeps the address. Without saying much, let me show you something here. Okay, you can see this structure now. The first place it keeps a string, then it keeps the length of the string, then it has a what? This is a pointer called next. You can see this asterisk makes it a pointer. A pointer that keeps the address of a particular data type, which is what? Struct list S of this same kind of what? Data type. So it's still keeping the same address of this in this next. So if you created the first node here, right? Let's say you created the first node like this, then you created another node. Do this. So imagine we created the first one from here. Then we went ahead to create another one. But what the computer did, what the program did was to create another one in 304 for us. Then the next one starts from 5 to since 4 we give you 9. So if you have this way, then here let's say we save number 9. So this guy now, this address now is saving this address 304. So you can see that here is these two guys now, they are together. They are following each other. With this guy, we can have this guy. Same thing with array, that we see that the first one, with the first box, we can get the second. We can get the second one. They are following each other, but the memory, they are all together. This guy will have memory address of, let's say, 101, and this one must have 102. So, but in this case, you can see that there are two different memory allocations that we are doing. We are not doing them together at a time. You can actually do them together, but since we are not doing them together, you are creating one at a time. So once you get a value, you add it to this guy. So just the way to add it is get the address of the former one, the pointer, and keep the address of the new one, which is this, to it. So once you have this one, you can access its value. You have this first address. It's going to always return this 101 to you. So once you have this 101, you can access the address. You can access the value that you store here. And still the same thing, you can still find the address of the next one that you are pointing, the next memory space that your address is saved. The next one can actually be hidden somewhere far away, and you have other memory space in between that have other address. But by the virtue of this, since you're already having the address, you can reference that location. You can skip all these ones and reference that location. And once you reference that location, you can get the value and this. So this makes it flexible for the computer for the program to actually save the value in different boxes, memory box, not actually them being consecutive like this, so that once there is no enough space to keep more than that size, so now you are saving them in bits in different locations on your memory. So that's actually what the linked list is. So, but where the algorithm comes in is how, when you create this, how to link them together so that they can still follow each other. And sometimes you may find them in a ring form that at the end, this one, instead of pointing to another memory like it's doing now, you can come and find out that it's pointing to like 101. So you keep going in cycles. If you are transversing this particular linked list, you can see that you keep going round. So, hello, are you guys with me?
Yeah. Well,
Yes, yes.
Okay, just give me a minute. Just a minute. Let me just attend to something. Sorry, please.
it's okay.
David,
Okay, it's okay, it's okay.
sorry, please. Let me just attend to something. Okay, sorry for that. I'm back. Hello? Hello?
Yeah, I can
Hello,
hear you.
hello, we are
Yes,
with
I can
you, we
hear
are
you.
with you.
All right. Sorry for that. Um, so look at, we started from the structure. We looked at, okay, what's the structure, how to define this, how it's together. So, and that value that we pass in is when we start creating functions to handle those things. That's where that pass by reference and pass by value, you see the importance of it. Then you're going to be passing in addresses around of locations, memory locations, instead of passing the actual values. So this is a particular word structure. I want to use this as an example to do our work. We'll just solve one or two of this problem because we spend a lot of time already. So let's say uh, let's create our header file, right? Copy this and save it there. So let me come here to this. Dash one. You can see my screen, right?
Yes, you can see it.
All right. So let me just cd into this. At this. This just one section. So if I do just vi, and I'll call it, just call it main.h. So, uh, I can't do this. I'm just trying to set up the header file. So, let's see this. Just end the if here, and if. So I always like to put this to know the end of the if I'm ending. So I'm ending the main if. So, let's just include our headers here. So I would say H. Include standard library. Library dot H. So if I do this list, if I do ls now, you can see we have our main H. So now, let's just look at this particular problem, and as I'm solving it, I will be explaining it more in details. So they're just asking that write a function that prints all the elements of a list. Prototype size t prints this. This is the prototype. So you can see here they are passing what? An address of what? Of a header to the function. So we're going to consider this. So it returns a what? A node format. See example. So if star is not print 0 nil, you are allowed to use printf. So in our own, we just did this. Let me just get these libraries. I don't need to be including them always. Come here. So actually, they name their own list. And they actually name it list. So if that's the case, let's say execute. I rename it. Oh, we just leave it me. When we are using ours, we'll change it. So is there any question that someone wants to ask that you're not clear of? So that I'll just talk more on it.
Yes, sir. I'm not
All right.
exactly clear on the exact reason why we should pass, or the circumstance that will make us pass by pass argument
Reference
by reference and argument by value.
by value.
Yes, the when is needed, the right, the explanation, that one is not clear to me at all.
Why we need to. So okay, imagine in a instance that you want to change the value outside, but this function, like that function that we make use of, let me create a file here for just example sake. Let me say vi image main.c. So let's just say this is a function. We're defining a function. Int, right? Let's call it me. And we have int x. So we have a value outside here, but this function is not in this file that we want to create, we want to use. All what we want to do, we have a value that will be saved here. Let's say int y is equals to 8. But in the instance that we don't want to, we want to edit this particular value y from outside this class, but we want to use this function called, let me name it appropriately, change. You know, this is a global variable, right? And now we want to change this value outside of this what? This file, this particular what, this program, when this change y is being called. So you can imagine, you will say that, okay, why not let's just do y here and give it the new value that we want to give it here. So, but we don't want to do that in sense that we don't want people outside to have direct access to this y. We don't want to expose it. So, but we want to change the value here and do some particular manipulation down here. Let's say we still want to use y plus, say, int here equals to result, which is equals to multiplied by 2. So imagine a situation, we want to, once we call this n, we want this number to change. Then we want to what? Execute this. So there are some situations that you need to do that in your program. I can't really put my hand on one per se, but let's continue this thing. Once we are doing, I will explain to you. So now you want to change this value outside here. And now, if you try to call this function now, before you call this function outside this module now, this particular C file, you pass in the value, the address, it's going to change this and it will allow you to do it. There are situations that I think I'm writing some programs, I would say that it requires me to what? Change this value up here. This value that is up here, so that I'll be able to manipulate the value down here and continue what I'm doing, because I couldn't do the changing directly from this file. So I wanted to do it outside of this file. So I needed a function that will grab the address of this particular value for me. Then it will allow me change it from that other class. Once it's been changed, the value is changed here, and this particular result will give me will return the right result that I'm looking for. So there are situations like that. So, but I just want you to know that, okay, this is how this pass by value works. So once we are going, even though I couldn't give you now, I will drop, there's video that I'm doing concerning this particular algorithm and data structure. I will drop it for you people to just watch. Even though we are not in class, I will show you why you need this particular pass by value and pass by reference. It comes handy. You definitely need it. So even here in the assignment or in the project, you will see them doing something like, you can see here, this hello here. What they are doing here, they are doing referencing. They are not actually passing the value of hello. This hello that you are seeing here, this is structure. Actually, they created the structure. But instead of passing the first address of this structure directly to this particular this header. So what they did to this header is they pass the actual address to this. So instead of passing the value of this one, they pass the address. So that's what I wanted you to know. So you will see them doing this a lot in in the test, like the tasks that they are giving you. You see them asking you, they are pushing them, and so it's a safer way of passing the address, so that you won't tamper with the values themselves. So let's assume this is a size T print list cons. This is the structure that they want us to define. It's a list. So this is the first task you have to handle. We have to handle. So I'm just using this so that we'll have a structure that we'll go with. So write a function that prints all the elements of a list, L list. So we already know what L list is. List S, list T is. So this is the structure. So they are just saying that write a function that will print it out. Then return the number of nodes. So that means it's list that they are actually passing to us. So it's linked list that they are passing. So we iterate through it and print everything out. And return the total number of nodes. We are going to calculate, okay, how many nodes is inside. Then format. Then in the format, you see the example down here. So we see the example. Then if start, that's this one. If this is null, you have to print it out as 0, nil. You are allowed to use printf. So I'm going to look at that also. So the first thing is, this is sample 0.main.c. It's just a sample test for us to test our method. So you can see after doing it here, they call this, they are trying to create the linked list. So let's follow through and see. So the first thing they did was to create a pointer, and they name it head. So this pointer now is there to receive an address of a structure of this type. data type of what? List T is a structure, this structure that is being defined here. So once this head can only store what? An address by virtue of this, because we made it a pointer already. Then we have what we call new. So new too is a pointer. So he's pointing what? He's keeping an address of a particular memory block also of this same type. Then we have what? List T. So the first thing they say what? Hello. So you can see they went ahead immediately and instantiate it and put the what? And say the first string, this is it, and the total size is 1, 2, 3, 4, 5, and they put 5 because the length is 5. Then the next value is null. So the address, you don't know the address, so that's why they put it null. So because we don't know the next node, so there is no next node. I didn't mean there is next node, it's the address that they will pass here. So this is the first node, and it's hello. So they say size, they say n, size tn. So they are just declaring a variable here. They declare a pointer variable, declare a pointer variable here, then create an instance of this structure up here, one of it. And the next here that we're seeing is self-referencing. This structure is self-referencing. It's referencing himself again. So it's self-referencing. So it's referencing another structure of his type, of his kind. So after referencing this, so this one here is holding null by this, by virtue of this now. So here, what they did here was saying that, okay, head here now, we're expecting what? An address. So this hello now, it's a memory block. So instead of returning the actual value of this guy, we're returning the first address of it. So this hello now will hold the first address. So it's not the actual value we're returning, because if we say hello now, we're trying to get the actual value of what? This structure. So instead of getting the value, we want to get the address, the first memory block that saved this particular instance that we created here. So that's why we're doing this. Ampersand returns what? The address, the actual address, not the value. So we are not interested in the value. So I think that's where it comes into play, because you can't just call how will I put it? Okay. If we say hello here, yeah, we are saying that, okay, this guy and this guy, if we say just hello here, we are saying that this value here is equals to this. But we don't want to do that. We want to only save the first address of this to this. We don't want to assign this value that you are seeing here directly to the header. So that's why we want to get the address that these particular values have been saved. So the first address, the first memory block of their address will be returned. And once it's returned, it's going to be saved here on the head. So this is the first node in the list. Then you can see here they say what? New. So this new also is of type what? List T. So we say malloc, size of what? List T. So he knows the size. You calculate the sizes here. Do the addition. Once he gets it, he assign the memory space. Then we say if not. So that means if it wasn't successful, it's going to return null. That's what malloc does. So no need of typecasting. It will cast it automatically by this type that we have here. So once he does that, if it's null, you just print out error and return what 1, which is a return value for what failed. As error value, that means your program didn't run successfully. So the main process will be expecting an error, a code to be returned. So we return 1, code 1 back. Then here, down here, once this new node is being created, see what's happening here. They say new node dash what s string. So they are pointing at this node. Now they have created a memory block. So to access its own memory block, they are using this arrow this. So they are accessing this for this particular word string. They are trying to assign value towards to this string after creating it, because it's going to create this memory block for it, and this memory block is going to create, and this one, they are going to be what together, going to follow each other together. They are going to follow it together in the memory space. So you will assign for this, assign for this, and also assign for this. So once that is being done, this length now, it creates for the length also and assign 5 to it. Hello, you can see here it's hello. So 1, 2, 3, 4, 5. So he does that same thing. He did. Then he said next. This new one now, we say the next value is what is head. So you can see what's happening now, because this head now, we actually store the address of this first one. So if we say this new one next, where is it? Where we are? Okay, next is equals to head. So it's actually offloading the address of this hello that we saved here to what? To this dot next here. Just the same thing that we did here. So it's just like saying that, okay, the address of this one now, pour it here in this particular word space. So let me show you what actually happened there. Let me create it just the way they did their own. See this one, make it blue. Sorry. So let's say that this is the, I'm just giving this, not actually the size of it, but just for demonstration. So the same thing here that we have here. We have in the structure, we have our character, which is what? String. Then we have length, which is integer, and we have struct, which is what? The next address. So same thing here. We have this, we'll save the character for us. Then here, we'll save the value. Let's see. Hello. Then here we'll save the next address for us. Let's say 3, 4, 5. So when they, instead of returning this value, this first value, which is 5 here, because I didn't mean they call Just watch this. I don't mean this particular what? This particular call here that they did. I didn't mean they call just hello. It means that they are trying to return the first value on this, which is what? Which is 5. So, but we don't want to return this first value. If they just call hello, that hello that they name it, if they call it, it's just going to return this first 5. So, but it's not this 5 that we are after. We are actually after what the address here. So that's where you will see that they are using these dollars, and that's why I make mention of the pass by reference, because if they actually pass it by value, it's just the first address block that is going to return, and it's just that 5 that is going to pass into it. So, but since that's not the case, we want the address, so that's why they pass it here. So the head now, we already know that is what? It's a pointer. So he's holding the address of this hello here, which is this. So, and we are offloading it here. We are offloading the value of the head to the next. So this is our new listing that we've created, and we're pushing it. So this is where he's storing it. So once he stores it here, the same thing, that the value of the header is coming here, and hello world still there. Then after he offload it to the next, so you can see now they are saying head now becomes what? New. So let's see what they did here, and if you understand this, then I think we're good. Let's have this. So let's assume that this first one is being created. Let me do something, if it will work. Let's arrange this side by side. So this first one that they did now, this is the structure that you have the head and everything. So this hello now, this hello that we're saying here, let's just name it here. Hello. See what they call it hello. See the picture. Then this one is new, so we say new here. Let's say new. So this new, this okay. This one I can make it. Let's see, you found it at 5. Right? Then what he did here was the first one is the string. So this first one is world. Then this second one is 5. Then this is no, there is nothing in here. So this is what this first one they did here. This is just how it is. Created another one, this memory block, but immediately after the malloc, you're going to have empty. It's going to be empty here. It's going to assign this. I'm going to be null. So there is nothing inside this. So what they did, what's happening here is this header now is just another memory space. It's another variable called head. It's just a single this head. So what it does, it just keep address. So, but at this point, he didn't keep any address. So here now, once we are here now, what we did here was to collect the address of this particular one. Because if we try to call hello directly, it's going to give us only world. Instead of giving us, and we want to take this entire address. So if we call this, it's going to give us the first memory block that is going to return to us, not the entire everything. So, but we want everything to get everything. So we need the address of this first one, not actually the value of this first memory block. So that's why we did this here. So it's going to return this address. So this ampersand is to return the address. So once you return the address of this first one, the address is going to be saved here in the head now, because head is a pointer. So now head now is going to be carrying 101. So see what's happening. It's carrying 101, right? And head 2, he has his own address. His address is 8. So just see what's happening. He too, he has his own address. This is his own address, but he's keeping the address of what? This hello. By just doing this, we are just saying that, okay, this address here, keep it in here for us under what? Head here. So this just what's happening. So instead of returning that, then we did this malloc now. This malloc now went ahead to create this particular space for us. Then we check if it is null, because it's going to return null if it's not successful in creating this memory block. So, but since it's successful, then we say, okay, new. This is how to access every attribute of this particular structure. So we're saying label string. So we access the string and we say, okay, duplicate this particular string now, hello, and save it in here. So here now we'll still 5. So here they say, okay, the length on the length n, put 5 there too. So put 5. Then the next here, this next now, see what they did. They say, okay, next now carries what? Head. So head now that is returning is not actually returning this address. You know, this one, when we did the hello on, we put ampersand. But see what they are doing now. In this case now, they didn't put ampersand. And since you didn't put ampersand, that means you are actually offloading the value of this guy, the content that this particular word head is holding. That's what you are returning, not his address. So if you are returning it, you are going to be returning address 101. So they said, okay, put address 101 here. So this is what just happened here now. By just doing this, it's returning address 101. Then now they say, okay, this head now, after returning this head now is empty. And this head now still has 101. But they are saying, okay, now it's not 101 now that we want again. Here now, this new now, we want you to return what? New now becomes this. So just see what will happen now. This entire new is going to be returned here. It's going to carry the first address. We're changing the entire everything, so it's going to be 501 here. So he's holding the address of what? This new head. Holding the address of this new. But just see that this head now is just a pointer. He's not actually holding this structure. This structure is on its own. This head now is just the address that he's holding. So as he returns this, this head now becomes this. This head now becomes this. It's this entire stuff now that you're now changing this one now to this. So new still exists, but now head now is pointing to the same memory as new now. By doing this, they are pointing to the same memory. So just like saying this guy is pointing to this guy. So now he's pointing to this by just calling this. So if you say n is equals to print list, so this is our function that they expect us to create. So you can see they are passing what? N now. So what they did here was to pass head by value. So if they are passing head by value, that means they are passing what? 501. So that's what I was emphasizing. I didn't mean they put ampersand here and do this. They are passing it by address. So they are giving us the address of head. But since they didn't put ampersand, there are some situations that you see that they are putting what? Ampersand. But since they didn't put ampersand here, they put head here. So that means we are actually offloading 501. So it's the address they are actually passing here to us. So we're going to be anticipating what? An address, to get an address inside our function. So this is the function that we're going to define. Then it does the freeing for us. We don't have to worry about the freeing. We'll talk about this freeing later. So let's just try and solve it. You can see this is the example. This is how we want our program to print out everything. So it prints this one, 5, and hello. Print the next node, 5 and hello, and at the end it returns what? The number of the elements that we actually read. So if it is null, return is put 0 and nil. Then if it is not, do this, and the same thing here. So let's try and implement this and go to the code and just implement it. So let me copy this. This is their code that they want us to use to test to see if our work actually passed. So let me copy it. And hello, I guess everyone is following what we did here and it's more explanatory.
Yes.
If you're not okay, you can still ask questions so that we'll still go.
I'm okay with just that. I'm just trying to get the exact the reference and value, why you must use one and the other.
Okay.
The full picture, yes, that's the one that is not
Okay.
extended. Even though it's
Explain to us. What do you understand by value, pass by value, and pass by address, and by reference?
what I understand by pass by value is passing an actual value into the function as an argument. What I
Yes.
understand by pass by reference is passing the address of the value
Okay.
as argument into the function. Yes. But
Yes.
why must you use one? And why must you use the other? Why is one necessary? Well, this is only in C language. I had done a little bit of JavaScript before coming here, and there's nothing like this.
Yes.
Anyway, there are no really pointers there, Sha. So I
So
want to just know why you must. Because at the
use
point, ALX was doing too much of pointers and reference inside the function. So there must be a use case. There's a reason
and
why
this
it
is the use
is
case.
necessary.
And yes, I told you that there is a use case along this their tax. So this is the use case here. See what they did here. Instead of just calling here, see this particular line. You see what happened here. You know that to get an address of a variable, you use this ampersand.
Yes.
Okay? This ampersand now, what is doing to this hello now? It's not actually returning the actual value of what? Hello. The content of hello is not returning the content of hello. It's returning what? The address of hello. Yes. So that's what we did here. You return this first address here. This 101, the first block address. He returns it here. Then what he did next now, yeah? Here, this head now, just look at what happened. After we've created this and assigned the values to this particular word structure that we define, then they make it to reference what? The head now, to reference hello. So once it's returning, they say it's equals to new. So what they are saying that new and this one now becomes what? One. So instead of just returning the first address, they are making them to be the same thing. So if they say this is equals to this, so it's returning what? The first address here. Let's go further. Once we are doing this thing, I will show you. I will change this. Instead of receiving this particular this, then we'll see what will happen. Then you understand what we are saying. You will see the error that it will throw. Okay?
Okay.
You will see the error that it will throw at us. Then you see clearly why it's more important to you sometimes to pass by a reference, because you are dealing with memory. So if you are dealing with memory, most of the times it's good to pass by what? By reference, because you actually want to change the value of these guys. Because if we just pass head to it, let me see. Okay, let's look at it first. Let's just implement this. So our function is just going to return an integer. So size in print list. So const list t. Okay. Sorry, let's see what's the print list const and list of type list. So we have once we have our h, we know that we are returning a value. So the next thing that we'll do, we create something, let's see, a variable that was going to return our size for us. So it's t, and call it note. So number of notes, and leave it like this, or we can initialize it to 0. So it's empty. Can create a pointer. So whenever I'm iterating through a linked list in C, I like to create my own pointer that will get the address and put it in there. Then instead of iterating from this, changing this value, I'll have the address that will keep changing on it. So I'll say list t goes to ptr, call this as a pointer. So I can go ahead to assign it immediately. Give it h. This h that I'm receiving here, I want to upload the address that is coming here to this. So now I'll come down here, I will say while ptr not equals to no. It's not PTR that I'm supposed to check. I'm supposed to check this next. Next is not equals to no.
And the no is supposed to be in capital.
Okay, sorry. So used to my JavaScript. Been working on project on JavaScript. Pardon me, please. So you have this. So if it's not equals to no, so that means because at the end of it, you can see here what happened is when we do this. I'll put the address of this here. This one here. This becomes the head. This becomes the head here. By this last distance. So the head now is holding to this. And this one now is holding. You can see there is null here. So let me make it capital letter. Null here. This one is holding the null. So anyway that this next, because we know that this value is next. So whenever next is null, so that means it's the end of the list. So we are looking for the one that has null. So we know that okay, we've arrived at the end of the list. So if it is null, don't even go to the next one because we're going to reach the end of memory. We're going to have issue. So we say better still. Okay, let's just do it this way. We'll correct it. Then we'll say num puts plus. So we add it. And what we'll do, we'll say if ptr dash string is equals to null. So we want to do print f. Then we'll do we say if it is nil, what should we do? If it is nil, if star is nil, you print 0 and nil. Okay. Yes, you can use this. So if it is nil, just go ahead and just print this. You can do this to stage surface. Okay. So put this bracket and put our nil inside. So else print f. assign D is let's see the example here. Okay, just print the string. So just do this. S, right? I haven't forgotten. So
Yeah, S is for string.
yes, S is for string, right?
Yes, yes.
Okay, so that's say PTR. Now we say dash. This will get the N length LEN, comma PTR. We'll get the string str, and we'll close it. Have this. And after this, after the while, so after the while, we will return nodes. So because so now we have to do some checking. So always check some errors here. So we say if H, so I want to check the H itself. If H is equals to no. I want it to return return 0. Let's return 1 as an error. What's another function for error? Return code for error. There's those standard values for errors. Can anyone remember anyone?
I'm not sure now, but I think it's ampersand too. No, not so sure.
No, there is standard code for errors.
STD. She's just mixing up in my head. One STDERR. STDERR. On that. That one
Standard
is the
error.
function. STDERR, yes. That's on that. I don't know when to use this one. When to use
Yes, that's what I'm looking for. I forgot. I think
yes.
this error like this, right?
Yes, yes.
Okay. I don't want to go start googling it. To take our time. We're already just trying to rush and say, that's what this one. So,
Is the class on record?
I don't think so.
Oh, yeah.
And don't worry, I will send a video to you guys.
Okay. Please, thank you. I appreciate it.
This one is just live, this thing I'm doing, so I will share a video with you tomorrow.
Okay, thank you.
I just want you to see my thinking process, so that's why I don't rehearse. I just come so that we are doing it. You are seeing how I'm thinking about it.
Okay.
You understand? So because if I go ahead to just do the solving, I won't be able to see how I'm seeing it. So I want you people always, when I'm with you guys, see how I'm looking at it also. Okay. That's why you see sometimes I'm making some mistakes. So now we have this pointing to this. But if here we start checking for next, the first node will pass, right? This one, if we come, because our first node is okay, we check the next, it has next. So this is not node. He enters, he do next. So now we need to put something that we need to change this. We say PTR now, okay, is equals to the next node value. So we say it's equals to PTR dash this next node. So it's equals to this. So actually, I don't really need this. So we don't need to check the next, because if we still say we check next, when this guy becomes null, we're going to have bad memory. So this is okay, this is fine. So I'm looking at, is there anything we are leaving out? Okay. So if there is not, yeah. So I think we're through with our function. We are through with our function. Let's come here and see. To execute it, we need to use this. So let's see if it will compile. Do we have 0.main? Did we create that file?
No, I'm not sure. I don't think so. So it's not compare.
Compile. Let's create it. But you understand what I'm trying to do?
Yes.
Okay. Program that they write, they're trying to just test the program that we are writing. So after creating this, they pass it to the program and expecting it to return a certain value, then they will test the values here. Let's copy and try. Let me see. Okay, let's do next line. So let's try and run it again. Compile it. Oh, okay, we didn't add it to our header. So it won't go. So let's add the prototype to our header. Prototype here. So let's try it again. So we have 0-print where the problem comes coming from. This guy is supposed to be a pointer. So yes. Assign value to it. Then the error, this standard error, is it complaining? If it's complaining, let's return 1. That means it's not successful. We'll still come back to it. We'll look at it before. We can Google it together. What is it saying? Saying print list at edge in function print list error initialization discard const qualifier from pointer target type. So initialization discard const from pointer target type. I think we didn't do something right. Size T print list const is th. Okay. Coming. So is T const H. H is returning, yeah. So if this is a constant, that means this is going to force this will return the value of H of a pointer H. So I define this guy here and we pass in so it's still throwing the error. Assignment discard const qualifier from pointer target type or discard disqualify. Let me try something. Just hold on. Hello. You guys are there?
I'm there, but I think the rest might
Yes, sir. Still here.
Okay. So this pointer issue that we are having here. Come in, let me see. Let me wrap my head around it. Error assignment discard const qualifier from pointer target type. So if It's of
I
type
think
list.
you should Google the error.
Coming. Say V0 dash print. Um, print list cons list th. Does it want this guy to be constant also? I don't think so. No need of making it constant now. This thing is just making sure that I'm not passing it by reference, passing it by value. And here, I don't want to temper with this. Temper with H. Can't be changing H. Let me just try something. But this is not a good practice, but I just want to see it through first. I want to manipulate the actual H itself. So I think he needs me to pass that constant to the list T that I'm creating also. It should have a constant definition. But so it's a bad practice what I just did. Because sometimes I would still need that. Let me show you something. VI. Yes. So why I'm complaining that it's a bad practice? Because sometimes after this iteration, I will need this. Now I've lost the head of what? Of my list by doing this. So now if I need to do other things with the list, I won't be able to. Because here now, the address here now is null at this particular point. So if I need the address to do something outside here, I won't be able to do it. So why I was able to get away with this is because I don't need it elsewhere again. So after this, because I'm changing the actual value of this. So let's try and implement it the right way. That's the way I tried to do it before. Let's see if it is the cons that's the issue. I don't think it should be. But So which topic are you guys on now currently? Hello?
Hello. So, I'm a little bit ahead of this. Their own. It's just that a lot of some of the concepts I don't understood. Because right now we are on Monday. We are starting Airbnb.
Okay, that means you've gone into Python already.
Yes. Yes.
Okay. Buying Airbnb. Okay, that's nice.
Mm.
That's
Even
nice.
though
You've started doing the real stuff.
we will be needing your help in things like this. Because
That's the real stuff. Now you will appreciate what you have been doing so far, because now it's not making any sense to you. I know definitely.
yes.
Mhm. Now once you start seeing what you are doing, it's coming to it's fleshing out. You really like it. So you still be doing your JavaScript again. They'll introduce you to React and the rest.
That's good.
Mhm.
But we've not done Flask. I don't know. And we're supposed to use it in the Airbnb.
And you've been introduced.
How come now? We are not doing anything on Friday, tomorrow. Then till Monday, and we are starting to Monday. So
And they're giving you time now to take break now and also read about it yourself.
hey, read about the Flask. They never tell us to read about Flask and anything. I think I saw
They're not
somebody.
supposed to tell you to read about most of these things. You're supposed to be researching, be curious about them.
There are many things to do. You can use React to do it. You can use Angular to do it. You can use Django, Flask, Spring Boot, use Java. Many things. So you're supposed to tell somebody that we're not going to start killing ourselves.
So you see where the problem is coming, right? So it's the constant that I didn't give it on the other one. So when I'm declining the other,
Typecasting. That is another thing.
it's not typecasting. So that one is different from the typecasting. So it actually works. So let's view it and see. 0 dash print is, so see, this is it here. So is this constant that I didn't put? Since this is coming with a constant, this h is coming with a constant. I need to put the h.
Okay, that's true.
So that's where the issue was. That's where it's throwing. So because it's trying to discard this const. So since this is a constant, let me use this also. So now the h will still be there with the header address. So if we do it the other way, we're going to lose the address. If we need h to do something, we still need the linked list to do something. Won't be able to. So I think this is the first task we just solve now, and you can see how we go about it. First of all, because we need to return the total number of it, we go this way. And you can see that the first address, what I'm checking here is the address of PTR. Here is the address that I'm looking at. If this address is empty, because since I'm receiving the H here into this, receiving the address of the first node block into this one. So that's 500 in our own case, based on our diagram here that we did. So is this 500 now that we're receiving here? So if you check here, 500 is not empty. That address is not empty. It's not null. So it will pass through and count, increase this. So that means we found one. So we increase our note here. Then we check if the string is equals to null, because they give us condition here that we should check in the situation that the star is null, print it this way. Then they give us permission that we can use the printf. So that's why we're able to implement it with the printf. I go that route. So it depends on the constraints that they give here, the instruction here. So it depends on how you're going to solve your work. So, and I always use these examples here that they are giving, this sample to test run to see if my code is actually working. So I always utilize this test before pushing it up there. So most of the times, 80%, if I use this test, it always check. So sometimes it's just that there are some edge cases that you won't check. So like checking for that null there in this particular place, checking for this null. Sometimes if you don't do it, they may end up passing null to see if you actually check this edge case. You understand? So if you actually handle it, it will pass. So it's a good practice to always don't trust what the user will send to you. So that's what they are saying. Don't always trust what the user will send. Always check it yourself. So this is it for this particular one. Should we still look at another one? No, we'll call it a night.
Yeah, sure. Well, I don't mind looking at one, but I wish you.
Let's call it a night. We can rest because I've been sleeping and waking up.
No, but if you're up to it, I can stay with you now. If some guys got to rest, they can rest. If you're up to it, Mr. Benjamin, I don't mind, dude.
All right.
I hope I'm not being greedy. I want to find out something.
All right. So
Majority are tired anyway. We can still call it a night anyway. I don't know.
all right. So, but basically, that's it. And this.
I want to know how you use the test to test it, actually.
Okay, you didn't see how I use the test?
No, my baby was crying. I had to go and deal with him.
Okay. So during the testing, what we did is, they always give you this block, this hash block that you're seeing here. This code that you always see during your project.
Yeah, that's the main dot C and something, right?
Yes, this is the name that they expect you to save the file with. So
Yes.
you can see it's a command. They are telling you that, okay, this is the command that we run. Cat. So they run cat, and this cat now, they are calling this file. So this file now is displaying its content here. So basically, they are telling you that there is a file in your directory. You should have a file in your directory called 0-m.c that the content should be this. So once you have this content,
basically you just copy this now, then open the file now.
Yes.
You even try to compile it with this their GCC here. Without that file, I think it even give you an error. But I'm even seeing the 0main.c file there.
Yes. So you just follow the steps, and also we use the compiler, the.
But how are you testing with it then? You said something like you were testing. Maybe I didn't understand you. I just.
Okay. So we've already created our function. This is the function here. So here in this example that they give here, you can see they are actually using the function. They are calling the function that we're going to define because they are actually expecting the function to come. So if they are compiling with our own, you can see they include our file that they are expecting us to create here. You can see it in the. So once this file, we created this file, and that function is present inside it, and we also include it on our header. That means this print list function is going to be available. So this is what they are using it to test. So it's at this point that they pass the head of the linked list to our function. And we have already defined the function. Here we receive the linked list here and create a variable that will keep the number of the nodes in the linked list. Then we went ahead to copy the address of the header and push it to another pointer and create another pointer. Sorry, we create another pointer here. Then we try to check if they actually pass an address or this value is null. The user didn't pass any value. If he didn't pass any value, he just wants to return 1 back to them as an error. Then if that's not the case, if they actually pass a value to it, we want to go ahead and what? Change and pass in what? The value that H is holding here. We are offloading the value of H to this.
But wait a minute, okay, Mr. Elisha, right? Sorry.
Yes.
After that, if
Yes.
for example, I think that
H.
N is null. That's if H rather, if the value the user entered,
Yes.
right,
It's null.
generated an error.
Yes.
Yes, if it's null. If you generated an error, I thought you go like from there else or something, you just went to return that, then continued. I mean, I thought maybe the next line would be contrary to that.
Once
That's if it's not null.
No. Once this is null, the program will terminate here.
Okay.
Because once you return a value, this other part will not continue executing.
Oh, okay, yeah.
You understand? So,
Yeah.
but we already know that, okay, if they actually pass the value here, this particular one will not execute. It's going to skip it.
Mhm.
So we are going to
Yes.
reach here. But in the case that they
Okay.
pass a null value, a null as the list, so definitely we are going to reach here, and we are not going to do this here. Because if we pass a null, we're going to have issue here. You understand? Here in this while loop. So doing the assignment and the rest, we're going to have issues. So that's why we are just checking the edge here to make sure that, okay, the user wasn't being corny here. He actually passed what we expect him to pass.
Okay.
So then we go here, we offload the value of the first address here to PTR. So we check if PTR is not null, because we are going to still iterate over. So that's why we're checking that, okay, at the first instant, is it null? If it's not null, go ahead and increment the number of nodes to 1. That means we have a node. So we increment it, then we check that, okay, is the string null? Because here they say if the string is null, we want you to print this. Else, this is what we want you to print. You can see the sample here. We want you to print the length in square bracket and string. So that's what we check here. If the string is not null, if the string is null, is equals to null, print this. So this is what we did. Then else, that means if it's not null, that means there's a value in it. So go ahead and print the number in curly braces and the string. Then we pass them here. And we went ahead to do what? We found that this guy is available, right? Then we found the next address. The next address is saved under this value next. So then we are changing the address that PTR holds to the next address. So now this one will be pointing towards to the next node at this point. So it will still come back here to this while and still check again. So if you find the next address, which is you're definitely going to find, if you do the first one here, if you do the first one, you'll find this one, and you do the printing. You will do the second one. You will find the address here. Then you will do the printing. Then if you do the next here again, you will assign this null now.
It will be null.
Yes, so PTR now becomes null. So if it comes here to check, is it not equals to null? No, it's equals to null. So he won't continue. He will terminate the while loop. Then here now he will come and return the total number of nodes that we're able to count here. So that's basically what they asked us to do, and this is the execution, the simplest way we can execute this. So
Wow, man.
actually, if you want to make this simpler, there's what they call ternary operator. You can remove this if and then just do one single line, but it's going to be long. So
No,
So
let me
that's-
just wrap my head around this.
So that's what is happening here. So it's just basically you understanding pointers and also
Yeah.
pass by the value and passing by reference. Because now you can see what this const is doing. It's actually forcing this to pass in by what? By value. That's what it's going to do.
Okay.
Yes,
Okay.
it's forcing it to pass by value. He doesn't want any mistake that okay. You will go and be changing the value from inside here. You go and change the value of h that they actually passed through. Because if they didn't put this constant here now, I can go ahead and change the value of h outside from this example now here that they are doing. I will have access to it here, and I can tamper with it. You understand? So that's why they are putting this const here. So this const now will not allow me to change the address. It will just force the value to submit here, even though it's address they put, to force the value to be submitted. So I think that's just it. So I will reach out to David tomorrow. There's a video that I will share with you. I did the recording. So.
Wow, I really love to see it.
All right. No problem.
I don't know if I have your number, though, Mr. Elisha.
No, you don't. Well, are we connected on LinkedIn?
I don't think so.
So, all right, you can get my number from David.
Okay, very good. Please, I'll send you a message. But where do you live? What town do you live in?
I live in Abuja.
Wow, really? I live in Abuja too.
Yeah, I live in Abuja. I live around.
Please, I can't come and sleep in your house, I beg.
All right, no problem. You're always welcome.
I need classes. I live in area 1 anyway.
All right, we're close by.
Oh, wow, great.
I think if I stood on my roof and shout, you will hear me.
Oh, really? Where do you live?
Yeah, I say, since you are living in area 1, if I stand on my roof and shout, you will hear me. I live at that.
Okay, no wahala.
All right. So, thank you.
Okay, thank you.
Thank you. Thank you, Mr. Elisha.
They can unmute and maybe can say good night to one another.
Good night, Mr. Elisha. Thank you for having me.
Run out. Pascal, you see the?
Of course, man. I still did.
I believe you one day. I believe you one day. Okay, everybody. Thank you so much, guys.
All right. Thank you, everyone. Thank you, Mr. Elisha.
Thank you, Mr. Elisha. Good night.
Good night, everyone.